morning again. How are you today for Monday? Fine. Sleeping? I'm sleeping? No, nothing. Can you remember some word of chromatography that you studied last week?
Separate.
Separation. How about another word?
HPLC.
HPLC. Yeah. Another?
DC.
DC, HPLC, DC, that's all. Thank you very much. And for today, as you tell me about GC. Last week, we have learned about the HPLC principle, how to separation using the HPLC. And for this week, we're gonna study about how to separation using GC. The GC stands for gas chromatography. The difference of the GC and HPLC is the separation using the mobile phase. For GC, we are using the mobile phase as the gas phase. And the compound that separate using the GC. The principle of the separation is similar to HPLC. The difference is the mobile phase. For GC, we use gas to mobile the compound or the analyte that separated in the column, and then gas will mobilize our target analyte to the detector. And the separation principle is depending on the compound, the structure, and the polarity of the target compound. And I conclude the principle of the GC separation into 4 parts. First, we start from the sample introduction part or the flow rate or the flow rate control. Okay. At the moment we are waiting for the projector, so I will translate to you. For the first part, is the sample introduction. In this part, we use the pump to pump out the gas, the mobile phase, to the system. And after that, after the mobile phase flow into the system, we are going to the second part is the introduction of the sample. You can see in the slide, in the introduction of the sample, we use like a saline or we call injector. In this part, we need the heater box to vaporize all of the target analyte to be gas, to completely vaporize to be a gas when they are go through the system. And after that, the third part, what is the third part of the GC? The third column, the column, yes, the column or the separation part. Column is the main important part of the chromatography because this part we use column to separate or partition or dissolve the target analyte. Each target analyte have different partition coefficient with the column. Therefore, the separation occur when the different analyte with different partition pass to the column. And how about the last part of the GC is detector? Yes. Thank you. For the analyte that have separated from the column, the gas will flow or the mobile phase will flow to the detector. For the detector part, the function is detect what is the analyte and how many or the concentration of the target analyte. So this is the like a total flow or the total principle of the GC. And the instrument of GC have the principle same as this slide as well. So the next slide on the next, before we go in deep to each part of the instrument, I am going to show you the chromatogram. You can see that the chromatogram of GC is similar to the chromatogram of the HPLC, but the peak is more narrow and symmetry because of the viscosity, or it's like the gas will move faster than liquid, so we can obtain the chromatogram of the GC like a more narrow and more symmetry. And if you saw in this slide, there are how many compounds in this chromatogram? How many compounds that we detect? 5. A, B, C, D, and E. Okay. For the quantitative analysis, it's the same with HPLC. We can use the x-axis like a retention time to check the peak of the target analyte. And for quantitative analysis, you can see in the slide, we have 5 compounds, right? A, B, C, D, and E. Yeah. So my question is, which compounds that have the lowest concentration? Do you think? The D. Yeah. How to see in the chromatogram? Why you think D is the most lowest? The short P or narrow. Yeah. How about another? Do you have any another idea? Narrow, shorter, or high order, smaller or lower? Yeah. For the quantitative analysis, in this slide, you say that D is the most lowest, and because we can see that the intensity of D is the most lowest, and also if we consider the peak area of the D is the lowest as well. For quantitative, after detector detect that the chromatogram of each target analyte, and also the peak area or the peak intensity is related to the concentration of the target analyte. And this slide, I show you like the general of the GC chromatograph. The instrument of the gas chromatography, sometimes we call the gas chromatograph. This is the name of the instrument of the GC. The GC, the format or the design of the GC is similar to the oven. It's like the square rectangular oven. And then we have the like a auto injector. And the different detector have a listed different format. If for frame, the GCFID or the frame detector, the detector is in the part or in the behind of the GC, so we cannot see in this slide like a burner to frame the ionized. And this is the GCMS. This is the GC instrument part, and this is the MS, like the mass spectrometer or the detector. And this is the portable GC. The portable GC is designed for supporting the monitoring system or for the environmental analysis. We can move the portable GC to more like a screening test to real-time monitoring or real-time sampling, and then inject at the sample sites. This is the example of the gas chromatograph that launched or benchmark in the system of analytical chemistry. And we are going to go in deep of each part of the GC instrument. In the GC instrument have the like a 4 part similar to the GC principle as well. So let's start from the first part. The first part is the sample introduction. In the sample introduction, as the GC have a gas, we use gas as a mobile phase. So there are different types of gas can be used for my mobile phase. But the most important thing or the most important property of the mobile phase is inert. The inert, the nitrogen and helium are the most inert gas that we use for the mobile phase. And for the mobile phase, sometimes in some book or in the instrument or another company, we call it carrier gas. The carrier gas is mean that it's the same meaning with the mobile phase gas. And another property of the mobile phase should be high purity, because if there are, you can see this slide, if there are another hydrocarbon or the moisture or the oxygen, we need to trap this contaminant first before it go into the GC instrument. The carrier gas should have high purity to make sure that in our system of GC contain only our mobile phase gas and only the sample, our vaporized sample, to be sure and we can confirm that our system have a good accuracy result when we writing the report for analysis. You can see the different color of the different gas. The different color is mean that the different type of gas, for example, helium have a brown color, nitrogen is a green color, and some of, as I ever tell you, some of GC have a red color gas. The gas tank of red color is mean that the gas of the hydrogen. Hydrogen is not carrier gas, but hydrogen is only the gas that we need to use for the flame ionized detector. This is the general property of the carrier gas. And after that, now we use the pump to flow the gas, and then we trap the contaminant. Now the gas is passed through into the system, into the GC system. And this part, the carrier gas have flow in the system. In this part, we need to inject our sample into the system. I mean, for this sample, there are different types of the injector design. In the previous many years ago, we used the manual sliding. You can observe that because the GC sample, we need only less amount of sample, less amount than HPLC. So the sliding, we use the name is microsiring. It's not only siring. The micro is the mean that the volume that we use is in microliter level. But now in nowadays, in GC, they have decided to be the automatical or automation. So we can use the auto injector. And in auto injector in the GC must have this part, and we saw it in the red. It's called the heating box. The heating box, have a function that it can help the compound to vaporize our target analyte, even in the liquid, in gas, or in the solid, to be more completely vaporized or the gases as well. And for this slide, you can see that the sample was introduced or was injected from the outside, and then before pass to the column, they need to vaporize in the heating box. At this part, in this part, we need to fix the temperature that we sure that the temperature that we fix have higher the temperature of the boiling point of our target analyte to make sure completely vaporized. And then now our compound pass into the column for separation.